Hello everyone, my name's Againsta and welcome back. Now I know it's been a very long time since I've been recording a video. It's been over a year since I've done that, but I'm back and I'm ready to give you more. This video took a long time to edit, so if you like this video, please make sure to subscribe, and it helps me a lot. Seriously. Thank you. Now, let's begin. We are going to be doing the life cycle of a star. Now, the life cycle of the star. So, we're going to go till the evolution of the red giant. Once the core runs out of hydrogen, fusion stops in the core. Only helium is left in the core, but it is not yet hot enough to fuse helium. Hence, once again takes over and the core begins to contract. The contraction generates heat, which flows outwards, which raises the temperature of the hydrogen shell surrounding the core enough to start hydrogen fusion. This energy starts to heat up the surrounding layers, causing them to expand. Meanwhile, the helium core continues to contract, generating more heat and causing even more hydrogen to fuse. Stars actually generate more energy in this stage versus when they were on the main sequence, which is why they become more luminous. This energy flows outwards, causing the star to expand even more, hence becoming cooler but still more luminous. So now we're discussing the lifetimes of main sequence stars. As you can see here, the lifetimes of main sequence stars. So we have spectral type, surface temperature, mass. So basically the mass of the sun equals 1. So that's 1 solar mass. Lifetime on main sequence, years in years. So you can see the O5 is the spectral type. The surface temperature is 54,000. So it's 40 times the mass of the sun. It's so 40. That's a lot. And here, the lifetimes of the main sequence is 1 million years. So it has 1 million years for its lifetime. So that's basically what my chart is. And then we're going to be doing about the thing about where we do the chart. So time to become the red giant or the supergiant. So you can see that in my chart, you can see that I've drawn many lines about it. So the figure, the solid black lines show the predicted evolution from the main sequence through the red giant or supergiant. So basically red giants are big or very big, but they're not as big enough to be a supergiant. A supergiant is massive. It's really, really big. So each track is labeled with the mass of the star it's describing. The numbers show how many years each star takes to become a giant. Red line is the zero-age main sequence. While theorists debate the exact number of years shown here, our main point should be clear. The more massive the star is, the shorter time it takes to each stage life. Yeah, so it's not as good to be a massive star, but it will be more luminous though. So this is the picture here. So all the stars in an open star cluster, like NGC 3293, form at about the same time. The most massive stars, however, exhaust their nuclear fuel more rapidly. So the more rapidly they do it, the less time of life they have. So that's the main point of the last one. So evolve more quickly than stars of low mass. As stars evolve, they become redder. The bright orange star NGS 3293 is the member of the cluster that have evolved most rapidly. So then you can see using the star clusters, you can see two charts here, and yeah, you can see the charts. So basically, cluster M41 is older than NGC 2264 and contains several red giants. Some of its more massive stars are no longer close to the zero age maintain like the sequence. The ground-based photograph shows an open duster M41. Note that contains like several orange color stars. These stars have been exhausted hydrogen in centers. So then we have the main sequence turn off. So you can see in the three, it's turning. So it's like waving. The first one is just a line, and then the second one is kind of a turn, and then the third one is like a very short one. So after 4 billion years have passed, many more stars, including stars that are only a few times more massive than the sun. I mean, our sun. So they're basically declaring it as our sun. So one solar mass. Our sun is one solar mass. So that's how other stars are actually like compared to our sun. So this means that no stars are left near the top of the main sequence. Only the low mass stars near the bottom remain. The older the cluster, the lower the point on the main sequence. And the lower the mass of the stars is, where stars begin to move toward the red giant region. The location in the HR diagram where the stars have begun to leave the main sequence is called the main sequence turnoff. Then you can see that the global cluster of it and the evolution of a sun-like star. So this is basically a chart here. So the main sequence, evolution to a star of its sun mass. You can see there's a hydrogen envelope, hydrogen shell fusion, helium core, helium fusion, carbon oxygen core. The evolution of a star of the sun mass, main sequence is 11 million years and 6,000 surface. So always the surface temperature or any temperature in the space is always measured in Kelvin. Whereas here we do like Fahrenheit or Celsius dependent. So it's always Kelvin there. It's just easier to measure, but that's how they do it. And the luminosity is 1. So the luminosity actually depends. So if you become a red giant, you actually become more luminous. So the diameter is sun is 1, so it's basically 1. It's exactly the same. So the helium core is actually another thing. So once the star had runs out of hydrogen to like burn, you take the helium core. So that's basically it. Yeah, so these are some of the things that you guys can learn about. So yeah, this is the first video. I can upload more videos for you guys if it really means it. Please make sure to subscribe to my channel It really, really means a lot to me. Thank you for all of them who are subscribed. I really appreciate you guys for subscribing to me, and I'll upload a lot more like this. And I'm sorry for taking a long break. It's just that I just got distracted by other things. So that's basically it. Hope you guys enjoyed this video. This took a long time to edit. I already said it, but yeah, make sure to subscribe and watch my videos. So, bye. Hope you guys have a great time.